Hello everyone, this is Niteen Mohod and today we are going to see capacitive transducers. Capacitive transducers are basically the transducers which deals with the change in capacitance with the physical parameters. Capacitors basically work as per equation for the capacitance of parallel plate capacitor, and that equation is C is equal to epsilon A upon D. That is, C is equal to epsilon 0 epsilon r A upon T, where A is overlapping area of the plates in meters square, D is the distance between two plates in meters, epsilon is the permittivity of the medium, epsilon r is the relative permittivity, epsilon 0 is permittivity of free space, which is a constant 8.85 into 10 raised to the power minus 12 farads per meter. Here we are using permittivity word number of times. It's basically a measure of an obstacle or obstruction produced by the material in the formation of electric field. Here, capacitance changes due to change in physical parameters like overlapping area, distance between two plates, or dielectric constant. And this is possible with the change in physical variables like displacement, means displacement will change the overlapping area, force will change the distance between two plates, while the pressure will change the dielectric constant. Here we have shown a parallel plate capacitor with one plate as a fixed plate or bottom plate as a fixed plate and the top plate as a movable plate. Distance between this plate is small d, and the displacement of the plate can be done like this, either to right or left. Capacitance of this capacitor will increase if the overlapping area increases, that is, this plate is moved to right, and if the overlapping area is reduced, that is, if the plate is moved to left, the capacitance will decrease. Capacitive transducer is used for measurement of linear displacement as follows. Change in capacitance due to change in overlapping area of the plate or change in distance between the two plates. From equation C equal to epsilon A upon D, capacitance is directly proportional to the overlapping area, while it is inversely proportional to the distance between two plates. Hence, these transducers are used for measurement of displacements from 1 millimeter to several centimeters. Graphically, variation of capacitance with displacement is as shown below. Here, capacitance is shown on the y-axis while the displacement is shown on the x-axis. And you can observe that graph is very linear except some non-linearities which are due to the age effect of the plates. For parallel plate capacitor, capacitance is C is equal to epsilon A upon D, and since the plates are rectangular, its length into breadth, that is length into width, can be taken as area. So therefore area A is x into W, so you will get epsilon x into W upon D farads, where x is the length of overlapping part of the plates in meter and W is the width of the overlapping part of the plates. Now we will see one figure. Here we have shown top plate, bottom plate, means both the plates of the capacitor, and a dielectric material. This is the dotted portion which you are seeing. This is the dielectric material which is inserted up to certain distance, and the area of the capacitor in which the dielectric exists, that has got the length of L2, while the area of the capacitor where there is no dielectric is having the length L1. D is the distance between two plates, while W is the width of the dielectric. Variation of capacitance due to change in dielectric constant is the principle used here. So variation of capacitance means change of capacitance. How? So due to change in dielectric constant is the principle used here for the measurement of displacement. Initial capacitance of transducer. This capacitive transducers, initial capacitance will be C equal to, when there is this situation of the dielectric, at that time C is equal to epsilon 0 W L1 upon D. we have taken epsilon 0 and L1. Epsilon 0 because there is a free space for the length L1. Therefore, epsilon 0 WL1 upon D. While for the length L2, you are having the dielectric material here. Therefore, plus epsilon 0, epsilon R, that is relative permittivity, WL2 upon D. This equation can be rewritten as C is equal to, we are taking epsilon 0 W upon D common. So into bracket we will get L1 and plus epsilon R L2. So we will get this equation. This equation is important and you have to keep it in mind. Now we are making some changes. We are pushing this dielectric into these plates with a distance, small distance x. As we are displacing this dielectric inside the plates, this distance L2 will be increased by small x, so L2 plus x, while this distance L1, which was initially free from dielectric, now it will be reduced by x, so it will be L1 minus x. Total length will remain as it is and the remaining parameters will remain as it is. Thus, capacitance change or capacitance changes will be, now here capacitance, initial capacitance was C, now the change in capacitance is delta C. So total capacitance now we are considering as C plus delta C, and that is equal to epsilon 0 W into bracket, initially it was L1, so now here L1 minus x upon D plus epsilon 0 epsilon R W into bracket L2 plus x upon D. By adjusting the terms on the right hand side, we can get epsilon 0 W upon D common, and into bracket we will get L1 minus x plus epsilon R L2 plus x. Now epsilon, by again opening these brackets L1 minus x and epsilon R L2 plus x and bringing the terms of L1 and L2 together, we can rewrite the equation at epsilon 0 W upon D L1 plus epsilon L2 epsilon R L2 as a first term, and second term will be plus epsilon 0 W upon D Wx upon D into bracket epsilon R minus 1. That is C plus delta C is equal to, now this is what? This is actually the C, so we can write or replace it by C plus this term as it is. Now C on the left hand side and right hand side will get cancelled, and finally we get delta C, that is change in capacitance, is equal to this term. On the right hand side, W, D, epsilon R, epsilon 0, they are all constants, and therefore we can say change in capacitance is directly proportional to the displacement x. So I hope the transducers, that is capacitive transducers concept, is clear to you from the expression and from the changes or variations we are seeing in, we have seen in the capacitance changes due to different parameters, physical parameters. I hope this is clear to you. Thank you.